Welcome guys. So today we are going to solve the LeetCode daily challenge, populating next right pointers in each node second. We are given a binary tree. We have to populate each next pointer to point its next right node. If there is no next right node, the next pointer should be null. So basically given a binary tree, and its structure is like this: a val and left, right and next pointer. So we have to assign the next pointer of each node such that it points to directly right node in that present in that tree. So also it has a follow-up. You may use only constant extra space, excluding the implicit stack space which we use in recursive call. So after reading the question, the first thing that comes into mind is like level order traversal, in which we will traverse from each level, and in each respective level we will assign from the first node to the last node directly next nodes to its next pointers. Like in the first level it has only one node, so next will be null. In the second level 2 and 3, so we will assign next pointer of 2 directly to 3, then 4, 5, 7 in each in a single level, then 4 next pointer will point to 5, 5 next pointer will point to 7, and then last will be null. So it's a brute force. Like we will do the follow-up question a little bit later. Now let's focus on the normal brute force solution. So what we will do is like we will do DFS node root, a vector of root, which will store all my nodes in vector form with respective levels, and a variable to denote current level. If root is null, then we will simply return. If storage.size is less than equal to level, i.e. in the storage the level in which we are going to insert the current node is not present, so we will just push back an empty vector. Now in the storage in the storage of current level we will push back the current root, and then we will call to directly left node of the current root and increase our level by 1. Copy pasted this and just rename it as software. So basically we will first reach at 1, then 2, then 4, then again go to 2 and then 5. So basically the order of the push will be maintained as we are like DFS. So first all the left and then the right, so the order will be maintained. Now vector of root, storage, and current level is there, DFS, storage, and 0. At start we will take the topmost level as 0 level and root. Now as we are done with the level order traversal and we have our nodes arranged in the order as they are present in a level. So the task left with us is to just assign the next pointers as storage I j dot next is equal to storage I j plus 1, and then we return our root. So this line just assigns the next pointer of the current node to the next node present at that level. So we'll try to run this. So, oh shit. Node start. Here also node start. So it's running fine. Let's submit this. It got accepted with runtime of 3 ms, faster than 99.2%. So this is the brute force approach. Now we will move up to the follow-up. You may only use the constant access with IE. We are currently using a space of order of number of nodes present in the tree. So we have to reduce this. So I will remove the code. Now after the brute force, we have an idea that the thing is like in a given level we have to just assign the next node of a node, next pointer of a node to directly right node present in the tree. So now instead of using a DFS traversal and a storage vector to do all this stuff, we will use 3 pointers of type node and we'll do our thing. So basically now I will tell you further that what these 3 pointers are doing. So pointer 1 is a dummy pointer which will just help us to reach the leftmost node present at a certain level while we are traversing. Pointer 2 just help us to get back to the node of which the next pointer we have to assign to the directly right. Like if we got the ptr1 as 2, then we first store ptr2 as second, then we will assign the next pointer of 2 to 3, and then we will move ahead to 3. And the pointer 3 is used to just traverse the whole binary tree. We will run our loop till pointer 3 not equals to null, i.e. we have traversed all the whole binary tree, and at last we will return the root. Under this we will just have a bit of pointer shifting. So at the first we will check that if the left of current pointer of the current ptr3, i.e. the node traversing in the binary tree, has its left child or not. If it is present, then we will simply ptr2 dot next is equal to ptr3 dot left and ptr2 is equals to ptr2 dot next. So you might have some question that why we are assigning the ptr next to the left of the current node. So the answer to this is like we are at number 1 node, so the ptr3 will point to 1. It has some left node. So basically if we are at level 0, we are assigning the next pointer of level the next level. We are not like assigning, we are not. You might have some question that why we are assigning ptr2 next is equals to ptr3 dot left. So the answer is that if we are at level 0, we are trying to fix the next pointer of the next pointers of the next level. So the left child of 1 is 2 and we will just shift our pointer ptr2 to 2, and then we are like continuing the process of assigning next pointers. So if ptr3 right not equals to null, then ptr2 connect, and then like we are at first, we forwarded the ptr2 to 2, and then we are checking that ptr1 dot right i3 is present, and we are assigning the next pointer of 2 to 3, and we are doing it the right that the question is saying us to do. And now we are doing like ptr3 dot next ptr3 is equals to ptr3 dot next, and inside after this for loop we are doing like ptr3 is equals to ptr1 dot next and ptr1 dot next is equals to null, and ptr2 is equals to ptr1. Now let's run this. It's working fine. It got accepted. So I'm also pasting this all the 2 codes on the PasteBin, and the link for the same is available in the description. See you soon.